All right. Okay, so we are going to discuss histograms. In order to do that, we're going to talk a little bit of vocabulary. For those of you watching on Zoom, you won't really be able to see the whiteboard. I don't think this cord, no, it's not very long. But I will take pictures of the whiteboard and post them when we are done. Okay, so histograms. Some of you are probably familiar with a bar graph, yes? You worked with bar graphs a lot when you were in elementary school. And to really understand the difference between a bar graph and a histogram, we need to have this little conversation about the different types of variables, okay? So the words that I have on the board right here, quantitative versus qualitative variables, okay? So quantitative variables versus qualitative variables. What words or what parts of words do you see hidden inside these that kind of might give you a clue as to what type of variables or what type of data qualitative versus quantitative might be? Last class, when they saw a word that started with Q, they said, oh, it's quarantine. We're going to talk about quarantine. That's all we think about now. COVID and quarantine. But quantitative, what word do you hear inside of there? Quantity. Okay, so quantitative data or quantitative variables has a lot to do with quantity. What is quantity? How many? Yeah. Okay, what about the word qualitative? Quality, good. Now, this is not talking about how great something is. Okay, it's not saying it's a high quality piece of machinery. That's not what we're saying here. When we talk about a quality, we're talking about something that you have, okay? So a quality about me is that I have blondish hair. A quality about me is that I live in Payson, okay? So that is something that describes me. It's kind of like a category that I fit in, okay? Another word that we sometimes use here is qualify. So do you qualify to be in the group that likes apples? Do you qualify to be in the group that has a high GPA? Okay, whatever it is. Okay, so if I asked you what city you live in, would you say that's a quantitative or a qualitative answer? That's qualitative. Okay, something about you is the quality of living in Payson or living in Santa Quinn or living in Genola, or yeah. What about if I asked you your GPA? Your GPA is what kind of a variable? It is quantitative. Why? It's basically a measurement of how many A's you've had, right? Okay. Any sort of measurement is going to fall into the quantitative world. Okay. Anything that's just a word or a description of you is going to classify as qualitative. So quantitative, you're answering with numbers that are a measurement or a count. Qualitative is when your answer is words, usually, okay? However, there are a few exceptions, okay? I was born in September. Okay, my birthday is on Wednesday. We want to celebrate. It should be fun. Okay, I have all these meetings on Wednesday. I'm like, that is not nice. It's fine. So when I ask you what month were you born in, okay, if I say September, that's clearly qualitative. I answered with a word. But if I say I was born in the 9th month, does that change it? Is it now quantitative? Am I talking about how many or a measurement? No, the 9th month in September are still the same thing, okay? So even if I answer with a number, that doesn't necessarily mean it switches over to quantitative. You just have to think about, is it a measurement? Is it telling me how many of something, okay? There's a question on your homework that asks if the numbers on the back of a football jersey, okay, is that qualitative or quantitative? How do they get that number? Is it their weight? Height? What is it? For some guys, it's kind of like their nickname, right? Or their signature. Yeah, like my little boy, he's 10 years old. He is obsessed with the number 20. And he is determined to always be the number 20, no matter what. I'm like, I don't know if that's going to work out for you, but good luck. Okay? And so he always says, oh, you don't have to call me Hunter. You can just call me 20. Okay, whatever. So for him, it's kind of like a nickname, which it kind of is for other boys too. Like, do most football players, do you have a number that you want every year? Nothing. Okay, I don't know. Okay. Okay, so quantitative, we'll put things like your weight is quantitative. Your GPA is quantitative. Give me another example of something that's quantitative. A measurement or a count. Can I think of anything else? Oh, age. Good one. Is age quantity or a how many, or is it a quality? Isn't age how many years you've been alive so far? Yeah, good. So age falls over here in quantitative. Okay, give me some examples of qualitative. We said maybe your football jersey number. Favorite color. Good. Favorite color. Let's do one more. One more qualitative.
What about like where you are in your like the middle child? What would that be? It wouldn't be quality? Quantity?
I think it would be qualitative because you're either the first or the second. It's not really, I mean,
it's like where you are.
Yeah, and it's kind of who you are. Like, are you the oldest child or are you the baby? Like yeah. Okay. I don't even know how to put that. What? First order. First order. Okay. Will not make any sense to people that are not in this room right now, but that's okay. Okay. So within quantitative, so quantitative is gonna be where we spend most of our time. Okay. In this class, we deal with a lot of data that is numerical, not so much the other. Yeah, we'll have surveys and stuff where people can choose their favorite color and stuff like that. But for the most part, we deal with things that are answered with a number or a measurement. So within those, within the quantitative variables, there are two different types that we're going to focus on. So I can't even spell. Quantitative splits into two groups. Discrete and continuous. Have you heard those words before? I think so. We bring them up sometimes in Math 3 and Math 3 honors. We don't study them like hardcore, but we do talk about it. So, discrete and continuous. The three that we listed are sort of, for the most part, all three of these are what we would call continuous. So weight GPA, and age could all be what we consider continuous quantitative variables, okay? But something like the number of siblings you have would be discrete. Can anybody tell me the difference between those two types of numbers or measurements?
One keeps changing while the other will end eventually.
Okay. Ashlyn, in your life, has the number of siblings you've had changed? Sounds a little weird, right? It does change. It just doesn't change like by little numbers, right? Does your GPA change? How many of you have had the same GPA your whole high school career? I did. Okay, that is probably one of the most common ways of defining the difference between quantitative and qualitative. I feel like it gets a little blurry. So let's think of another way we could define it. Okay, there's change and doesn't change. What about, sometimes people suggest decimals versus no decimals. What do you think about that? Does the number of siblings you have come in fraction and decimal form?
I would.
So there are a few exceptions. Sometimes we talk about half siblings. Sometimes maybe your mom is pregnant, so there's like almost another sibling, but not quite. Okay, but if we just talk about the actual siblings, maybe it's living in your house or not, whatever description you want, generally speaking, what kind of numbers are those? 0, 1, 2, 3, right? Do these have to be like that?
No.
If you were to ask me my age, right now I would very proudly say one number. Okay, but I'm not going to tell you that I'm like 37.999 because I'm about to turn 38. I would just say I'm 37. Yay, good for me. Okay, and then it just switches. It just instantly changes. But did it really? Am I really just 37 right now? Not really, if you want to get technical, right? So there's it's pushing it. Do you need me?
I gotta skip that on our. I gotta go run.
All right, you go have fun with that. I'll plan by myself, as always.
If it's short, I'll come back.
Okay, it's fine. I'll just do all the work. You can just sit in the back. Okay, I got it. Bye. Okay. All right. So discrete, number of siblings you have, continuous, your age. Okay. So that whole definition of like, is it because it changes? Your age is changing constantly, right? The number of siblings you have isn't really changing constantly. Okay. What about your weight? Is your weight constantly changing?
Yeah.
Okay. Here's a way I want to describe this difference to you. If two people got on the scale, some super cheap Walmart scale, and they both weigh 152 pounds, would you say that those two people weigh the exact same amount? Do you think you could get more and more technical and more detailed and fine tune it until you found a difference? That is the difference between discrete and continuous. Okay? If I have one sibling, does anybody else in this room only have one sibling? Really? Okay. Well, if I have one sibling and somebody else in the room has one sibling, if we dig deeper, can we find a difference?
Yes.
Between our one siblings, it's still a number. I have one, she has one. We both have one. It doesn't matter how finely tuned we count how many siblings we have. I'm going to have one, she's going to have one, right? So there's really no way to like distinguish between those two numbers. But our weights, on the other hand, if we get more and more precise, we can eventually find a difference. Okay? What about ages? You get more and more precise, can you eventually find a difference? Yeah, even if I found another person that was born on September 2nd, 1982, Could I still find a difference in our ages? Probably. Even if we were born at the exact same time, there's probably a difference in there in the seconds, right? From when she took her first breath and I took mine, right? Okay. GPA. This one's a little like, yeah, I don't know. I don't know if I would put this one in continuous or not, just kind of, because if I say my GPA is 3.98, that is all based on rounding, first of all, because when we say like, okay, you got an A minus, you got we always say 667 GPA points for an A minus. Is it really? No, it's 3.66666666666 forever. Okay, so it kind of depends on like what program you're using to calculate your GPA. But the fact that those decimals could go on for a really long time, I'm going to go ahead and leave GPA in the continuous category. Okay, so we're going to say discrete would be number of siblings. Could also be how many cars are parked at your house right now. How many bedrooms do you have in your house? So generally speaking, discrete is things we can count. Okay? Continuous is more of things that we measure or that we calculate. So number of siblings, but continuous would be things like age, weight, good? Any questions on those? You feel okay? Okay. So your first question on your homework assignment is going to be to take variables and decide if they are quantitative or qualitative. And if they are quantitative, you got to decide if it's discrete or continuous. I think after that whole discussion, the ones on your homework are going to be a piece of cake. I hope. Good? Okay. So I told you that we were talking about that so I could help you understand the difference between elementary school bar graphs and high school histograms. Okay? So elementary school bar graph, here we go. If you had to choose your favorite fruit out of apple, orange, pear, or strawberry, what would you choose? Raise your hand if your vote is for apple. 1, 2, 3, 4. Orange, raise your hand. Pear, raise your hand. Strawberry? 13. That's tall. We'll just wing it. Bar graph. What kind of data is this? This is qualitative. Are there numbers involved? Yes or no? Yes, there were 4 people that liked apples, 3 people that liked oranges, 2 people that liked pears, 13 people that liked strawberries. There are numbers involved, okay? But we put ourselves into categories. There's a category of apple lovers, a category of orange lovers. Yeah, does that make sense? So you qualify to be in this group because of which fruit you like the most. Okay? That creates bar graphs. Also notice, it doesn't really make sense for those to be touching. Apples and oranges aren't necessarily any closer than apples and pears. It doesn't matter what order we write them in. Okay? The most logical would have been alphabetical order. Oh, I did. Because there's really no other rhyme or reason to it. Right? Doesn't really matter what order I put these in. Okay? All right, now fast forward to high school. We want to make a histogram. We are not going to label with words. In a histogram, this axis right here is always a number line. Okay? So move over to, this is a bar graph. Move over to a histogram. And the axis has to be a number line. Now, the other thing that's going to happen in our histogram is that the bars are going to touch. We are going to move immediately from one bar to the next, unless there's a gap in our data, which we'll talk about. Okay? So, how many siblings do you have? I have one. How many? Okay.
11. 32. 32. 4. 3. 5. 4. 5.
3.
I counted myself.
4.
Okay.
Oh, Arlen.
Okay, I need to make this guy a little bigger. Hold on.
11. I'm so sorry. It's the greatest thing. I'm so sorry. Oh. Oh. I only have 11.
Okay. So we are going to start out with a still pretty basic histogram, okay? And then we'll transition it into the actual type of histogram that we're going to use in this class. But we're going to do it kind of quick, okay? So here we go. So first of all, here's a question for you. I'm going to put my y-axis right here, okay? Like, usually we call them horizontal and vertical axes. So they're not really like x and y variables usually in this class, but just so you're aware. Do you think that the bar for, well, I guess just for me, I'm the only person that only has one sibling. Do you think that my bar, how many, what's the one that we have the most of? Probably the 3s. 6 of those, so we just gotta make sure we can go up to 6. We'll do 8 just to be safe. Okay, so does it make the most sense to you to have my bar that represents me and my one sibling right there? Or do you think it belongs like that? Black or red?
Red. Nothing wrong with that.
I just want to know like what seems natural to you guys, honestly. Black or red? Okay. So because this particular data set is what? Discrete. Because this data set is discrete, you can actually do it either way. Okay. Because really this first bar, when I look at the black, this is saying anybody would be in here if they have somewhere between 0 and 1 siblings. Okay, but we decided we're not even going to let like the little 1/2s and those things in. They're either your sibling or they're not. They're either here or they're not. Does that make sense? So we're just counting those nice whole numbers. The red one, that would be anybody who has between 1/2 and 1.5 siblings. Either way, we would count everybody that actually just has one sibling, right? As long as, now this is something super important, as long as we explain in our histogram which endpoint should be included, okay? Because I'm going to go to draw this next one. I'm going to use the black one, just because I will mess up if I do the red style. I'm going to use the black one. When I go to make the next one, how many people had two siblings? There were 3 of you, right? 4. Oh, 4? Oh, wow. 1, 2, 3, 4, 5. Okay, I can count. It's fine. 1, 2, 3, 4, 5. Does it make sense to you that just looking at this graph, there might be somebody that says, oh, so this person had 0 siblings, and all 5 of these people had 1 sibling. Is that possible that they might misunderstand it that way? Okay. So what we have to do is we have to declare the endpoint convention. All I'm saying is there's a little note that says include the right endpoint only. So that my bars can touch and be connected, okay? Because they have to be in a histogram, they have to connect. So I say include the right endpoint only, which means this is not the people with 0 siblings. I didn't have any of those, so I didn't need to graph them. This is the people with 1, this is the people with 2, because I'm including the right endpoint, not the left. Okay, does that make sense? So we could go and we could finish this. What's next? The 3s? There's 6 of those, right? 1, 2, 3, 4, 5, 6. And so on and so forth, right? Easy? Okay, now we're gonna swap gears really quick. This next piece is called a frequency table. So number of siblings, frequency. So in our data, we could have had 0 siblings, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. Frequency is how many times that happened in our data set. So what is the frequency of 0 siblings? 0. We didn't have anybody with 0. There's no only children in here. Okay, what about 1? What about 2? 3? 4? 3? 5? 6? 7? 8? 9? 10? 11? 12. Okay, so that is a frequency table, okay, which you would see in this graph, right? This would go up to 1, this would go up to 5, this would go up to 6, right? This is going to be super important in this class. So that third column is relative frequency. What percent of the people in our study, this is our study, had 0 siblings? What percent? 0. What percent had 1 sibling? Could you figure that out?
0.
How many, what percentage of the people in this room have 1 sibling?
I think in high school.
1 person out of?
Social for NHS courtyard right after 4th period. Ice cream game. There'll be a party. Please come.
Are there 22 of us? Okay. Is that right? 6, 12, 18, 19, 20, 22. Okay. What's 1 divided by 22? Do you have a calculator? 1 divided by 22. So 4.5% of our sample has one sibling. What about two siblings? Where am I getting these numbers from?
Dividing the total number by the amount of siblings.
22.7% of our sample has 5 siblings. Nope, has 2 siblings. Yeah? We keep going.
3 divided by 6, what is that?
So now what? 6 divided by 22? So now 27.3%. Yeah? 3 divided by 22? 13.6%. What's the next one? Also 13.6%. What's this one? 4.5. Yeah? What should these numbers add up to, guys? These should add up to 100%. Sometimes they don't exactly, but it's usually pretty darn close. Okay? I have a question for you. If I change this scale over here to make it percentages, would the graph probably look the same as it does right now?
No. Wait.
How much bigger is this one compared to this one?
Oh.
It's 5 times the size, right? Is this about 5 times the size of this? Yeah, it is. So it will look the same, okay? What we're going to do really quick is I have to show you one more thing that's super important. That area of the rectangles in the histogram, the area of that has to match the percentages, okay? Well, if all of these bars are just 1 unit wide, like they were before, right? There was a bar right there and a bar right there and a bar right there. If they're 1 unit wide, think about the formula for area. If it's 1 wide, then how tall does it have to be to have this number? My bar would have had to be 4.5 high, so that 4.5 high times 1 wide would give me 4.5. Yeah? The next one, if it's 1 wide, would have to go all the way up to 22.7. Okay? But really quick, I'm going to show you these people, these families, if you have up to 2 siblings, so you, your 2 siblings, your mom and your dad, can fit in a car, right? Just a regular car. Mom, dad, 1, 2, 3 kids. Got it? Okay. If you make it an SUV, you get 2 more seats in the back, a small SUV. Okay. So 2 more seats in the back. So let's say you could have 4 siblings and yourself, and your mom and dad fit in that next size of vehicle. Okay. Then we go to like a Suburban. Okay. My Suburban, I could fit 5 kids and the 2, wait, 1, 2, 3, 4, 5, 6 kids, so 5 siblings. And then after that, you gotta have something larger. We'll just say a bigger van or a big SUV or some sort of, yeah? So instead of individual numbers, I'm gonna classify these by what type of car your family needs. So my first bar is going to represent all the cars. SUV, we'll call this a van or a Suburban, and then something bigger. Okay? So I'm going to actually make my bar this wide. It's going to go all the way to 2. But how high is it going to have to be? What percentage of these families will fit in a car? All that, right? Like 27.2%. So if this bar, this is the critical piece right here. If this bar is too wide, does it go up to 22 or 27.2? No, it goes up to like 13.65 or some weird number, I don't know. Okay, so I would change these to percentages. What is half of 27.2? 13.6. How are my math skills? Okay, so we'll say, and then just so you guys know, when you see it in your textbook, they'll actually put in parentheses the height, because when I just put a mark somewhere between 10 and 15, it's like, wait, where is that? So when you see that number, that's telling you the height. Okay, we didn't get to the assignment.